My goodness. Good morning again to everyone, and I apologize for the glitch as Zoom just not only refused to share a screen, but it also hung up my computer. So I was able to restore everything without rebooting. That's the good news. Bad news is we've lost a few minutes, and I'm re recording this lecture again. So let me very quickly summarize what I had to say, and I apologize for the repetition, but it will be necessary for those of you, a majority of you, seeing this asynchronously. So today we're going to cover Newcomb's problem, which is a very exotic species of the prisoner's dilemma. Very interesting game that you're all going to play once I show you the model and show you how to play it. And then we'll discuss the results in class today. Thursday, I will continue in my breakout group with a couple of applications of the Newcomb problem to reality, which is surprising, but it does have real-world applications as well as being an interesting game involving a kind of a predictor. So that's going to be this week's agenda. That will cover the remaining material that this course aimed to cover from the start. So next Monday will be a review. We will meet here, and I will be open to any questions that you want to ask about any of the materials that we will have addressed in this third section of the course. That is starting from Zeno's paradoxes, continuing to Anselm's ontological argument and the various objections to it. The prisoner's dilemma that we covered last week, both in the simple two-person formulation, both one-shot and iterated, and then on Thursday in the very important n-person variation where there can be many players, and that leads to Harden's tragedy of the common, so-called, and also to free riding. Those models I discussed on Thursday's class. Those of you in section M can look at them on Blackboard. And those of you who are not in my section can view an older recording, last year's recording of that same lecture, which is available on YouTube. And I'm going to email that link to your instructors and ask them to share it with you. I tried to share that link with you just now on a notepad, but the computer didn't want to do that. So I'm afraid we can't. I'm not going to hang up the computer again. I will paste that link back into the chat room for the benefit of those who are here and can see it. But for the rest of you who are watching or who will watch asynchronously, that link to my YouTube lecture on the n-person prisoner's dilemma and the tragedy of the commons and free riding will be emailed to your instructors. I'll ask them to share it with you. So if you want to further investigate this very important and applicable model, you'll have another resource for doing so, okay? Now, today we're going to look at Newcomb's problem, and you're going to see very quickly from the structure that it is, in fact, a prisoner's dilemma of a very exotic kind. And it leads us into quite a different kind of a game, which we will all play. And then, as I said, just to reiterate once more, next Monday there is no new material in the course. I will be happy to entertain any questions that you wish to bring to a review, and I'll record that lecture also next Monday. But you may ask anything that may still be puzzling you concerning Zeno or Anselm or the prisoner's dilemma in its many formulations, and or today what we're going to cover in the Newcomb problem area. And that will be next Monday's review. I will not lecture to you, but I'll be happy to review any of the materials that you wish me to, or indeed, hopefully, to answer specific questions that you may bring. And that will be next Monday, and I make that the today's the 29th, so next Monday will be the 6th of December already. And in fact, the week after that is technically our last class on a Monday, but since there's no new material and we will have reviewed everything else in this section, I'm going to give you a study break, which I'm sure you're all going to need to prepare for your final exams, or indeed those in my section M to submit your final essay, which will be due that day. Okay, so the 13th is technically our last day of classes, but our last meeting, which would be normally on the 13th, is going to be a study group or a study session rather, which you may use entirely for your own benefit to catch up on end-of-term work that I'm sure you all need and want to do. Okay, is that all clear on the housekeeping? Is everybody clear, or are there any questions about that? If you have any, please do ask. Everybody's okay? Clear. Okay, Jeremy, thank you for the feedback. So, without further ado, then, and with the hope that the screen share is going to work for the usual purpose, which in this case is just to share a PDF with you, I'm going to try, with my fingers crossed, to pull up the Newcomb problem slide. It will be much easier to conduct this game, to explain it, and to conduct it if you can see the representation, obviously. So just bear with me. Let's hope Zoom cooperates this far, and we'll find out in just a moment. Well, apparently it is. Is everybody seeing this? Could someone say so if they are?
Yes.
Great. Okay. So, this is called Newcomb's problem. It's named after the physicist, supposedly, who created it. It was first reported in 1969. It's a fairly new problem as philosophy goes. And it was reported by Robert Nozick, a very well-known Harvard philosopher who recently passed away. But he published the very first paper revealing Newcomb's problem and explaining his experiments with it, which he conducted with his own classes at Harvard, and I conduct them also here at City College. We're going to do it today, and you're going to get to see how you would behave in this dilemma, which it really is. But it's a little bit different from a prisoner's dilemma, because it's actually a one-prisoner dilemma, if you like, and not a two-prisoner dilemma. Your opposite number in this dilemma is a kind of demon called Newcomb's demon. But not to worry, this demon is a good demon, and the demon has a lot of money to give away, if depending on the decision you make. So let me explain the rules and the procedure. This is really quite important. In fact, it's vitally important that you understand the sequence in which the play unfolds. So the demon's going to move first. You as a player are looking at two boxes on a table, box A and box B. And box A is transparent, so you can see into it. And it contains $1,000. That's what the K stands for, right? That's $1,000 cash. And that is yours if you want it. So it's sitting there and it will be yours to claim when you make your own decision in this game. Box B, however, is opaque. In other words, you can't see into it. It's wrapped up in some kind of paper, and you can't see what it contains. But you know that it's either going to contain $1 million or nothing. Okay, that's going to depend on what the demon predicts about you. All right, so you're looking at two boxes, just to reiterate that. Box A is transparent, contains $1,000. It's there, you can see it, and it can be yours if you want it. Box B is either going to contain $1 million or nothing, depending on what the demon predicts. So the game unfolds as follows. First of all, the demon is going to make a prediction about whether you will choose box B only or whether you will choose both boxes. So if you choose box B only, you're going to get the contents of box B only, and it might be $1 million or it might be nothing, yeah? If you choose both boxes, you're going to get the contents of box A and box B. Box A is guaranteed to contain 1,000. Box B, you understand, may contain $1 million or nothing. So the first thing the demon does before you make your choice, the demon predicts what you're going to choose. Either box B only or both boxes. That's what your choice is. Now, if the demon predicts that you will choose box B only, it places $1 million in box B. If the demon predicts that you will choose both boxes, it places nothing in box B, 0 in box B, okay? So you can't see what the demon is doing, once again, because the box is opaque, box B is opaque, so the demon's going to predict your choice. Then if it predicts that you choose B only, it will place $1 million in B. You can't see it doing that. If it predicts that you'll choose both boxes, it places nothing in box B. Again, you can't see what it's doing. And then it's your turn. You're informed, okay, the demon has made its prediction, and the demon has taken the action associated with that prediction according to those rules, Rule 2. And now it's your turn. And once again, you're looking at these boxes. You can see the 1,000, and you can't see inside box B, but at this point you know it contains either $1 million or nothing. So your choice is either box B only or both boxes, yep? So are you clear, first of all, before we analyze the problem, and you'll see immediately that it's a prisoner's dilemma once we look at the payoff matrix, but just for the sake of understanding the procedure, are you clear about the sequence of moves? This is really important in this kind of game, that we follow that sequence strictly. So is everybody okay about the actual sequence of moves? You understand what goes on here? Ashanti says yes. Is that a current yes? Ashanti, yeah, it is. Jeremy is clear. Is everybody else okay with this? You understand the moves? How the moves are made? Naomi, yes, okay. Very good. All right, Suzanne, as long as you understand the sequence, then you can play the game. But before I actually ask you, which I will do soon, whether you would choose box B only or both boxes, and you may expect already there's going to be some divergence of opinion as to which is the better choice. We need together to look at the actual matrix of payoffs, which we're doing at the moment, okay? So here's how the game looks. Before we even go there, I've got to say one more thing to you just about the way the game is unfolding. You are going to imagine that there are a lot of players. You're not the only player. The demon has infinite amounts of money, and it's happy to give away money. It doesn't care whether you choose box B only. If you do, it puts $1 million in there. Beforehand, if it predicts that you will. I mean, it has unlimited money, so it's not going to run out of money. And its only interest is in making correct predictions. This is really what the demon wants to do. And if you can imagine lots of people playing this game, then you can also imagine you're standing online watching all these other players, and then your turn eventually comes. But you will have noticed one thing as you're watching all the people in front of you online who play the game. You will notice that the demon has a really uncanny ability to make correct predictions. It's not perfect, but about 99% of the time, if you're keeping track of the demon's predictions, you're going to discover the demon somehow is able to predict with at least 99% accuracy whatever the player is going to do each one in his or her turn. So this is what you will notice, and this, of course, will factor in. Those of you who are looking ahead will realize this is going to affect the way that you will maximize your expected utilities in this game, because the demon's success rate of correct predictions is almost perfect. So you may be able already to see where this is going, somewhat parallel to maximizing expected utilities in the prisoner's dilemma. Okay, so that's just a hint as to what's coming. But don't worry, we'll get there. So let's now go to the next slide, and we'll look at the matrix representation. And if you take a close look at this, I mean, the demon first is going to predict your choice, and then it's either going to put, if it predicts that you will choose box B only, it puts $1 million in that box, right? If it predicts that you're going to choose both boxes, it puts 0 in that box, right? Remember, box B you can't see inside, yeah? So that's what the demon does. And now you're told, okay, the demon has made its prediction about you, and now it's your choice, right? This is your turn to play. So your choice is either box B only or both boxes, right? Now here are the possible outcomes. Like a prisoner's dilemma, if indeed you choose box B only, and the demon correctly predicted this, then you're going to get $1 million. If you choose box B only and the demon didn't correctly predict it, which is a very small chance, mostly the demon makes correct predictions, but in this case, if you're unfortunate and you chose box B only and the demon predicted both boxes and put nothing in there, you get nothing, right? Your other choice is both boxes. And again, most of the time, if you choose both boxes, you're going to get the 1,000 that's in box A, but if the demon predicted you're going to choose both, and it puts nothing in box B. So if you choose both boxes and the demon correctly predicted that, you get the 1,000 that's been sitting in box A the whole time, but that's all you get. And you're hoping, some of you may be hoping at this point, that if you're going to choose both boxes and hope that the demon made an incorrect prediction, namely predicted you choose box B only, so it puts $1 million in box B, and you end up choosing both, and so you would, in that case, get the $1 million plus the 1,000. Okay, so those are the payoffs as they're defined by the game. And now those of you who have studied well what we covered last week immediately see that this is a prisoner's dilemma. Why? In terms of the payoff structures, it's always going to be defined this way. You have the temptation to choose both boxes, which is T. That's the biggest payoff to you, right? $1 million plus 1,000. You have the so-called, reward for believing that the demon will predict correctly what you're going to do. And if that's so, you're going to get the $1 million. All right, that's the reward, if you like, not for mutual cooperation, but for believing in the demon's high success rate and that it will apply to you too. So that's the next best payoff, is $1 million. The sort of punishment for choosing both boxes is that, well, you kind of know the demon's going to predict it correctly, but you're going to get that 1,000 for sure if you choose both, no matter what's in box B. So you get, as it were, the Nash equilibrium payoff, which is 1,000. And then, of course, the sucker's payoff happens in those very small number of cases where you, in fact, believe that the demon would predict box B only, but the demon made an incorrect prediction in your case and predicted both, so put nothing there. And so you believe in the demon, but the demon mispredicted, and so you get 0, and that's the sucker's payoff, right? So do you see that the transitive ordering of these payoffs is exactly analogous, in fact, identical to the ordering in the prisoner's dilemma, right? You see that? That's important. So you see that the form of this is a prisoner's dilemma. It's a special case of a prisoner's dilemma because the actual ordering is preserved, but in fact the sucker's payoff in this case is 0. That's just a special case. And you also discover that the temptation to choose both boxes is the largest payoff if you get it, but it happens to be equal to the R plus the P payoff. So those are just what we call incidental constraints on the model, but they don't change the fact that this really is a kind of a prisoner's dilemma. Is this much clear to you so far? Everybody okay with this? Okay, good. I mean, if you were paying attention last week, then you see this immediately. If some of you took the whole week off and haven't yet watched last week's Prisoner's Dilemma presentations, then you will be totally lost. But this is building on what we did last week, and I'm seeing from Sophie, from Ashanti, from several of you, that from Anastasia and Susanna. Okay, so you see that as a prisoner's dilemma. So here's the point. If it is a prisoner's dilemma, which it is, a very special kind, but nonetheless a PD, then it's going to be susceptible to precisely the same analysis as the prisoner's dilemma. It's a dilemma because there are two principles of choice that diverge in their prescriptions, right? That's exactly what we saw with the classic prisoner's dilemma, and therefore you should not be surprised to see exactly the same thing happening again in this case, which, of course, is the case. So here we go. And now we look at the analysis. So we can see that the dominance principle, just the same as in the prisoner's dilemma, the dominance principle will tell you, just by inspection of the payoffs, that you're better off choosing both boxes no matter what the demon predicts. You see the parallel? Why? Because if you choose both boxes, well, you know that 1,000,000 plus 1,000 is better than 1,000,000, right? Clearly, by inspection. And you also know that 1,000 is better than nothing, also by inspection, right? So you might be tempted to reason, and certainly appears to be valid argument, that no matter what the demon predicts about your choice, you're better off choosing both boxes, because the payoff is higher in both cases. Is that clear to everybody? Yes, no, maybe? Yes? Okay, yes, yes, I'm getting yeses. The usual suspects are saying yes. Okay, I'm glad that you who usually respond are seeing it, but I'm concerned. I want everybody to see this, because it is what we covered last week in a different context, slightly different context, but it is still the dominance principle, right? No matter what the demon predicts, your payoff from two boxes is going to be higher than one box, no matter which way it turns out. You're either going to get 1,000,000 and 1,000, which is more than 1,000,000, or you're going to get just 1,000, which is more than nothing. So dominance says you're better off choosing both boxes. Okay, but what's the other principle? Well, it's maximizing expected utility. And what we're interested in is the expected utility of choosing box B only, right? Now remember, if the demon has a very, very high success rate at prediction, and it could be arbitrarily high, it could be like 0.9999% of the time the demon is correct. It's almost 100% predictable success. So in this case, if it's very, very high, then the expected utility of box B is what? It's simply the probability that you choose box B only if the demon predicted it, times the value of that payoff, and the probability of that is almost 1. So it means that the expected utility of box B only is, in fact, almost $1 million. This factor disappears because it's going to be 0 times a very small probability of an incorrect prediction. So the expected utility of choosing box B only, your expected utility is very close to $1 million. And the expected utility of choosing both boxes, well, again, the demon's success is so great at prediction that if you choose both boxes, it's almost for sure, again, 0.99999% sure that the demon predicted it, and therefore put nothing in box B. So if you choose both boxes, you're almost certainly going to get the 1,000, but you're almost certainly not going to get anything, from the box B. So basically, your expected utility of choosing both boxes will be approximately $1,000. Again, this will be multiplied by such a small number, the probability that the demon incorrectly predicted, that it's really negligible. This is going to be the main factor in calculating the expected utility of both boxes, because this is probability almost 1, this is probability almost 0, so this kind of drops out of the equation. And so if you compare the expected utilities, you can see your expected utility of choosing box B only is close to $1 million. That's what you expect to get. Your expected utility of choosing both boxes is close to $1,000. That's what you expect to get. Well, obviously, $1 million is much, much greater than 1,000, right? And so maximizing your expected utilities would therefore indicate or prescribe a choice of box B only. And that's the divergence, right? So dominance tells you to choose both boxes because you're going to get a better payoff no matter what the demon predicts. But maximizing expected utility tells you choose box B only, because if you do that, it's very likely that the demon will have predicted it, and therefore you're very likely to get $1 million. Okay? So there we have, once again, the same dilemma, which emerges from the divergence of these two different prescriptions. Both of these principles is rational. That's the problem. Both of them are rational. Each one of them makes sense, but which one are you going to use? And it turns out that given the structure of the payoffs, you could do the math, you could do the algebra on your own, and it turns out that, in fact, maximizing your expected utilities will prescribe that you choose only box B, and the demon's observed relative frequency of correct predictions, in other words, the demon's success rate in predicting the player's choices, doesn't even have to be that close to 1. It has to be greater than a half. And just, you can do the math. Anytime the demon predicts correctly with a frequency greater than 1/2, if the demon's doing better than 50-50, you're still going to get maximizing expected utilities to prescribe that you choose box B only. So there's the dilemma. Some of you may be persuaded by both boxes. Some of you may be persuaded by box B only. Each one has a fairly robust justification. Yeah? So what are you going to do? Well, that's obviously the question. So once again, I remind you of the sequence of the game. You're looking at these two boxes. You can see 1,000 sitting in box A. It's been there the whole time, and it's yours if you choose both boxes. Box B will contain either 1,000,000 or nothing, depending on what the demon is going to predict about you. If the demon predicts you'll choose box B only, it puts 1,000,000 in there. If the demon predicts you'll choose both boxes, it puts nothing in box B. You can't see inside, and you won't see inside until you make your choice. If you choose box B only, you will then get the contents of box B, 1,000,000 or 0. If you choose both boxes, you'll get the contents of both boxes, which will be the 1,000 that you're guaranteed, plus either 1,000,000 or nothing, right? So the demon will make its prediction. Based on that, it either puts money in box B or nothing in box B. Then after that happens and you don't see what's happening, you're only told, okay, the demon has made its prediction and it's made its move, and now it's up to you, and the ball's in your court. Do you choose box B only, or do you in fact choose both boxes? We've seen that it's a prisoner's dilemma in terms of the payoff structure, and therefore we've seen that there are two divergent principles. Dominance will tell you to choose both boxes. Maximizing expected utilities, contingent on the demon's uncannily high predictive success rate, will tell you to choose box B only. And now the question is, over to you. I'm going to stop the share momentarily, and I'm going to ask the class. So you basically have to choose B only or both, right? Both A and B, or only B. Okay, without collusion, pretend you're really playing this game. We can't play this game for real because we could never raise that kind of money. I don't think anybody would fund this experiment if we wanted to play with real money, and we'd have a hard time finding the demon who could predict with any greater than a random success rate what you're going to do. So we can't really play the game, but I'm asking you to imagine that we're really playing the game, okay? So imagine you've been standing online, waiting your turn. Imagine you've watched a lot of people in the class play in front of you, and imagine that almost every time the demon correctly predicts what they're going to do, so that almost every time a player chooses box B only, they get the $1,000,000, and almost every time the player chooses both boxes, they get the 1,000, but there's nothing in B because the demon predicted they would choose both. All right. So now let's imagine that it's your turn to play, and I'd like you just to put in the chat room whether you would choose box B only or both boxes. Could you please do that? Okay, so we have a couple of people with B only. All right, it's not a contest because there's no right or wrong answer. Yeah, it's a question of which principle moves you, partly a question of which principle moves you more. There's going to be some other considerations that we'll introduce momentarily. Okay, so I see that only a few of you have answered. And, okay, here's somebody for both. We have so far a few people, 3 people choosing B only, and 1 person choosing both. Any more people want to respond? I would really be interested in your responses. That's both, okay. And if you're able to understand the game, if you've understood the game so far, then you should be able to make your choice. Okay, and I see again some B only, a couple of both. There are 21 of you in the room. Could I get a few more responses, please, so I could just see how they're shaping up? Okay, we have a mixture. This is always going to happen in the class, by the way. There's always going to be a division of opinion or a division of choice among the two principles at stake. Some people will choose box B only, and some people will choose both. Are there any more people who want to chime in before we proceed? I would like to see a few more responses if anybody wants to make them. Maybe you're shy, or maybe you're asleep. I'm not sure. But some of you have responded. Okay. So then I want to tell you, first of all, what's happening here, which is a division of opinion, right? We have a slight majority at the moment in favor of box B only, and a couple of people in favor of both. And normally we get this, okay? Normally the class will more or less divide between people who choose B only and people who choose both. And now we can label you. You now will have an identity that comes from this game. Anybody who plays this game, those of you who are choosing B only, you're called one boxers, okay? In the game itself, you're known as one boxers, and those of you who are choosing both, not surprisingly, you're known as two boxers, okay? So people who play this game, people who study the Newcomb problem, people who investigate the Newcomb problem are either going to be one boxers or two boxers, okay? There isn't any other alternative. And you could try this at home, by the way. You could try this with your friends or family and see if you're getting how many one boxers versus how many two boxers in your own setting. But most of the time, and I've been doing this a long time now with classes, and usually it divides up more or less 50-50, sometimes a little more on one side or the other, but there's always a mixture. So let me ask now, okay, so for example, Jeremy, you picked box B only. Could you give us your reasoning? Could you share verbally with us why you chose box B only?
Yeah, I think I chose box B only, probably because it's high success rate. I mean, I think if it's like 99% um, that he guesses correctly, then a 99% chance that I get a million. I think so. I think that's pretty good.
Yeah, so you're that's generally what people do, and maybe others who have chosen B only were persuaded by the same reasoning. Let me ask, Ashanti, you chose B only. Was it the same reasoning as Jeremy's, or did you have a different reason? Are you also persuaded by the high predictive success rate of this demon? Is that what?
Yes,
Yeah.
that's what persuaded me.
Yeah, okay. And that's usually, I mean, you see the point, right? As long as the demon's such a good predictor, then you have a pretty good chance, you would expect, of getting that million. But then again, there is this other principle called dominance, and it's certainly robust. So we have, for example, Susanna chose both boxes, and Jesse did. Susanna, what was your reasoning for both? Could you share with us why you chose both boxes? I see a message here. Are you able to speak? You don't trust the demon. Okay. Well, and Jesse, you chose both boxes also. What was your reasoning for that? Can you speak or enter it? Having trouble articulating the reason. Oh, well, I mean, listen, you guys, in this kind of a game, you're supposed to have a reason. I mean, you can flip a coin, but we're asking you to appreciate, what's philosophically interesting in terms of rational choice theory is that there is a good reason for choosing both, and there is a good reason for choosing one only. But there's going to be division of opinion over which reason is more persuasive. So, I mean, the standard reason, and both Susanna and Jesse have given different responses to this. Susanna doesn't trust the demon, and Jesse is still trying to figure out why. It's not about being wrong, Jesse. It's about, what do you want to win and what do you think you have the best chance of winning in this game. But as I've said, dominance reasoning tells you that you're better off choosing both boxes no matter what the demon predicts. All right, that's a legitimate reason for wanting to choose both, and maybe there are other reasons you can think of, but those are the two standard reasons. So what's interesting is surely that we have this divergence to begin with, that it's not obviously clear what is the best way to proceed, right? Such that everybody is going to be in agreement, and it's never the case. What usually happens is that you get this division between the one boxers and the two boxers, a division of indicative of being persuaded either by the dominance principle if you're going to choose two, or maximizing expected utilities if you're going to choose box B only. And what we often find, and what Nozick reported after doing this for many years at Harvard, is not only do you get a difference of opinion in the class, but it also turns out that the one boxers usually think the two boxers are being silly, and the two boxers usually think the one boxers are being silly. So that's also kind of an interesting thing. It tells us once again that you may think you're rational, and you may be rational, which is to say you have some principle that seems reasonable that guides your decision-making process. But what's really fascinating is that in rational choice theory, not everybody chooses the same way. And yet everybody pretty much considers themselves to be rational. And yet obviously there are two main principles at stake here, and there's no meta-rational way, and there's no real way we can say, well, one choice is more rational than the other. It's really going to depend ultimately on which one you find more persuasive, and that may be partly subjective, but it's certainly not easily amenable to analysis. Yet what we find empirically is, just like with the prisoner's dilemma, you're going to find that people will often end up with Pareto optimal outcome by both cooperating, and people will often end up with the Nash equilibrium by both defecting. So similarly here, you're going to get one boxers and two boxers, and they both have perfectly rational reasons for choosing, although I would still like to hear a more rational reason, if you don't mind me saying so, for choosing both boxes. Susanna, you said you don't trust the demon. Well, that might be true in your case, but we've said the demon's not trying to cheat anybody. The demon is just trying to make correct predictions, okay? And Jesse, you said you're still not quite seeing through your own reasoning, which is fine. You want to digest it, and that's fine too. Does anyone have a yeah, that's right, Susanna. I think you're making a really good point now, that that if you choose both, you're guaranteed the 1,000. That's correct. I mean, that's absolutely correct. That's the dominance principle. If you choose both boxes, you're guaranteed the 1,000 that's in box A. You know that there's going to be either $1 million or nothing in box B, right? Depending what the demon predicts about you, and particularly if the demon predicts you'll choose both, then the demon puts nothing in box B, but you're guaranteed that 1,000. Absolutely guaranteed that 1,000. And as Jeremy says, you also have a smaller chance of getting the 1,000 plus the $1 million, which is much smaller chance given the high success rate of the demon's predictions. But nonetheless, so you do have a good reason to choose both boxes. Namely, you're guaranteed $1,000. Whereas if you choose box B, it's all or nothing. I mean, you're going to become a millionaire. You're going to be no better off than you were. So it's, in a certain sense, a riskier choice with a much bigger payoff, right? In a certain sense. But both boxes is also, in a way, hedging your bet, because, you think, well, okay, the demon's probably going to predict correctly, but I'm still going to get the 1,000, so I'm still going to be ahead. I can't lose. In other words, if I choose both boxes, I can't lose. Right? Is that clear? That's better? Is that helping you to see the way these two principles play off against each other? So if you want to play it safe, in other words, another way of interpreting this, and there are many ways of interpreting this. I'm just saying that, we're looking from a rational choice theory perspective at diverging prescriptions, but you could interpret this in other ways, and feel free to think about it that way, psychologically or otherwise. If you're not a big risk taker, if you want to be guaranteed that 1,000, everybody can use 1,000, and you're going to be guaranteed that 1,000 by taking both boxes. So there's a good reason. You're guaranteed to win something. Right? Whereas if you choose box B only, you're either going to become a millionaire or you're going to get nothing. And so if you don't like that kind of risk, then definitely you should choose both boxes, because you're guaranteed a small prize, relatively speaking. And as Jeremy says, you have a chance of getting both anyway, just in case the demon incorrectly predicts, in your case, that, the demon predicted you choose box B only, you choose both. And so the demon made a mistake and gave you the million too. So, those are good reasons, presumably, or at least convincing reasons for being a two-boxer. And that's why then, we have this division of opinion in the class. There are always going to be one boxers and two boxers. I've got a very good friend who agrees. We agree. As a philosopher, we agree about a lot of things. But we generally disagree about Newcomb's problem, that we generally make different choices ourselves, and each one thinks the other one's being a bit silly. And if you read Nozick's paper, and I think the citation is available to you, Robert Nozick, Newcomb's problem and two principles of choice, that might be online as a PDF. It was published quite some time ago, 1969. So you'll see he analyzes this as well. From the perspective of what his students do, and you're always going to get this divergence. That's why it's a prisoner's dilemma. You're always going to have the possibility of divergence. Yeah. Okay. So is this much clear? There's another nuance that we need to inspect this morning, and it's going to illuminate something we haven't yet touched on, that has to do with the non-linearity of the value of payoffs. Different people will value money in a different way, depending on their own situations. And this also is going to influence potentially divergent kinds of choices in this game by the players. And I can concoct two different matrices. When I've done that, I'll share them with you in a moment, which will definitely illustrate that by choosing the absolute values of the payoffs at different extremes, one can definitely influence the choices that people will make. This set of payoffs is, we have 1,000 guaranteed and 1,000,000 possibly to be won. That's a good range of payoffs to produce divergence generally among students, because everybody could use 1,000, but 1,000,000 is obviously a lot more tempting, if you like. But if we could monkey with the payoffs and maintain that ratio of payoffs, that is, what the demon puts in box B, if the demon predicts correctly, if the demon predicts that you're going to choose B only, the demon puts 1,000 times more into box B than is already sitting there in box A, right? In other words, 1,000,000 is 1,000 thousands. So we can change the payoff structure without changing that ratio, and we can produce very, very different results, which I'm going to demonstrate in a moment. Now, I'm predicting something about your behavior, which definitely can be wrong. I'm not anything like the demon when it comes to making correct predictions, but I'm going to predict something about your behavior in two different scenarios, and we'll see if that turns out to be right. But to illustrate the point about the non-linearity of money, or in terms of the value of money, which is why economists often measure these things in U-tiles, right? We've seen the units in the prisoner's dilemma of the payoffs. They're just imaginary units of value, not money. Because there's a problem when we start introducing money as a payoff, and that is that a given amount of money is going to be valued differently by different people. So typical example, and I'm sure this is an everyday kind of example that would resonate with you. If you see someone on the street who's asking for money, okay, I'm not asking you to confess or to, or to brag or anything. I'm just saying, would you give spare change to somebody on the street? If they're, if they look like they were really in need of spare change, would you give them spare change, or maybe $1 if someone looked like they were really in need of it? Yes, you would, Susanna, most of the time. So would I. I think if a person really looks like they're needy, then we can part with that. Yes, so you'd give them $1. Okay, would you give them $10? No. Okay, because that's too much, right? Because $10 is significant to you, right? But maybe $1 you can part with. Okay, so this is my point. Now look at it from the perspective of the giver, also from the perspective of the recipient. Maybe that dollar that you can afford to give to a needier person, that dollar could be a huge amount to that person, right? That dollar is to you something you can afford to part with, to be charitable, right, to help somebody. So it's obviously not going to make you hungry that day or jeopardize your rent money or whatever, because it's $1 you can afford to be generous with it. But that dollar relative to your means is not necessarily worth that much, but relative to the person who's trying to put together a meal, that's a huge amount, right? That $1 means a lot more to the person who receives it in terms of its value than it does to the person who gives it in terms of its value. Is that clear? It's an important point, because we're talking about the same amount of money, right? We're saying it's $1, however you look at it. The value, the actual monetary value, doesn't change. It's a $1 bill, but the value to the person, in other words, the subjective value, what value attaches to it in terms of the person's need for that, or ability to part with it, is very different. So the $1 is a fixed amount, but the valuation placed on it by different people could be very different. Clear? Okay, is that clear? So now let me recast this. Suppose you're walking down the street and you give somebody $1, and suppose Bill Gates is walking behind you and Bill Gates gives that same person $1. Now, that dollar relative to your means, you just gave that person a lot more relative to your means than Bill Gates did, right? Because $1 still means more to you than, because somebody like Bill Gates or Jeff Bezos, who has 50 billion or 70 billion or however their net worth is, that's a lot more than all of us. So if they give $1, that's almost nothing for them. It's negligible. It's next to nothing, right? Whereas if you give $1, it's not nothing. It's something you're willing to give, but it's still worth more to you than it is to, let's say, Bill Gates. Is that clear? Right? Yeah, well, there you go, Jesse. Speeding, fines, and Finland are linked to salary. Interesting. So they fine you according to your means. Okay. So, but the point is that a given amount of money, even a fixed amount of money, is still going to have a relatively different amount of worth depending on a person's net worth. That dollar will mean more or less to them. Okay. So it means a lot more to us than it does to these super rich elites. All right. So now, with that in mind, let's replay this game with the same ratio, right? Box A in the original game always has 1,000. Okay, that's the way it was concocted. So box A always has that 1,000, and box B always has 1,000,000, which is 1,000 times more, which you're either going to win or not win, right? The 1,000 you can guaranteed take home by choosing both boxes, but you are going to be tempted to take home 1,000,000 if you have faith maybe in the demon's predictions, or scientifically you see the demon is a very good predictor, so those of you who chose box B were banking on that clearly, and you were willing to risk the zero, right? You were willing to say, well, I could take the 1,000, but I'd much rather risk getting 1,000,000 because I think it's a good bet. Yeah, that's basically the reasoning for maximizing your expected utilities. Now let me show you what happens if we change the actual absolute monetary values without changing the ratio. We're still going to keep the ratio of what's in box A to what is the biggest payoff potentially in box B, right? It's still going to be 1,000 to 1, B over A, but we're going to now heavily influence, I'm predicting, what you guys would choose and what I would choose, come to that, by altering the absolute values, not the ratios, but the absolute values. So let's take a look at the scaled, what I'm calling scaled payoffs, okay? And see how this changes things. So let me share the screen with you once more, and then you'll see that this is a big problem for economists, for psychologists, for philosophers, for all people interested in this. Yeah, Jeremy, I'm sure you do. I'm sure you do. But let's now share the screen, hopefully, so everybody can see where it's going. And this is a kind of an interesting phenomenon. Okay, it's called scaling the payoffs. All right, so does everybody see the standard problem? I put that back on the screen. Can someone respond and say yes if you are seeing it? Yes, okay, thanks, Jesse. Okay, so this is this. We've seen this game. Okay, so some of you want the 1,000 because hey, 1,000 is better than nothing. Let's take both boxes. We're guaranteed the 1,000. Some of you are saying, well, 1,000 would mean a lot to me, but I'm willing to risk. I'm willing to risk it. I'd rather choose box B only and hope to get the million. Okay, because the demon's such a good predictor. So that's the dilemma. Now let's scale the payoffs in this way. I'm going to now rescale them. Okay, so there's going to be $10,000 in box B. Okay, 10,000 in box B, not a million, but 10,000. If the demon correctly predicts that you'll choose box B only, it puts only 10K in there. Okay, and what's available to you in box A is no longer 1,000. What's available to you in box A, just in case you choose both boxes, is just $10. So you could see $10 sitting there. Okay, if you choose both boxes, you're guaranteed the 10. But you know that if the demon correctly predicts that you'll choose both, if the demon correctly predicts you'll choose box B only, then the demon will put $10,000 in box B. If the demon correctly predicts that you're going to choose both boxes, the demon puts nothing in box B as before. But now the payoffs are different. Same ratio, 1,000 times more in box B than in box A, but what's there is much less. Only $10 if you choose both boxes, potentially $10,000 if you choose box B alone. All right? So you're guaranteed 10 if you choose both, but you might win 10,000 if you choose box B only and the demon correctly predicted it. Okay, so how many of you, based on this model, how many of you would choose box B only? And how many of you would choose both? Again, if you choose both this time, you're guaranteed only 10. If you choose box B only and the demon predicted it, you're going to get 10K. So Naomi, B only. Okay, B only, Jeremy. And any more thoughts on this? $10 wouldn't do anything for me. I would choose B only. Exactly, Jesse, but it's the same two principles. Notice now what I have predicted, which I haven't told you, but what I predicted is that on this, changing this payoff structure, just the absolute values, not the ratio, just the absolute values, it turns out that most of you are saying, well, $10 is not going to change my life very much. 10,000 certainly would. So you're willing now to go for box B. And I would bet that some of you who in the original formulation were willing to settle for the 1,000, right, and choose both boxes, now you're going to say, wait a second, $10 is not going to make that much difference in my life, so I'm going to gamble that the demon's going to correctly predict my choice, and I'll go for box B only and hope to get 10K, because that would make a difference. Correct? Is that a fair way to assess the difference between these two different payoff structures? I mean, structures are the same, the two absolute values changing, right? So, I mean, Jesse sums it up well. 10 wouldn't do anything for me. I would choose B only. And maybe some of you who would have chosen both boxes last time to be guaranteed 1,000 are not so excited now about being guaranteed 10. So you're going to choose perhaps box B only in the hope of getting the biggest payoff. Is that fair to say? Do you see the point? We haven't changed the model. We haven't changed the way in which the two principles are going to prescribe, because dominance still says you should choose both boxes. But maximizing expected utilities still says you should choose box B only. But the actual choices in the class, I'm saying, are going to vary from about 50-50. Normally, you get a split between one box and both boxes. And when we change the payoffs this way, I'm thinking most people are going to pick box B only, because that $10 isn't going to do that much for them. Yes, it is interesting, and we haven't changed the model, and we haven't changed the decision principles. We've just changed the absolute amounts of money. The ratio was still 1,000 to 1. We didn't change that either. The payoff structure is still the same, right? Still a prisoner's dilemma. But by changing the absolute value of the payoffs, we're definitely able to influence the way in which the decision is made by the overall number of players, right? Overwhelmingly now, I'm expecting most of you would choose box B only, hoping for 10,000, because as Jesse says, $10 isn't going to change your lives that much, but 10,000 surely would. All right, let's say, does everybody get this before we do the other variations? Is this clear? How this changes things in terms of people's decisions? Are you still thinking about this? That's okay. All right, let's go to the other extreme. And I'm going to do the same thing, but I'm going to do the other extreme. Now suppose that box A contains $100,000, right? You could see it there, and it's yours if you choose both boxes. That's $100K. But to keep the model consistent, we make box B have a payoff 1,000 times greater, which is $100 million. So now it's the same problem, but you know that if you choose box B only, you're going to get $100 million or nothing, okay? If the demon has predicted what you're going to do correctly. But if you choose both boxes, you're guaranteed $100,000, whatever the demon predicts. I haven't changed the ratio. It's still 1,000 to 1 in terms of the ratio of the payoffs, but I've changed the absolute value of the payoffs considerably, right? So box A now contains $100,000, and all you need to do is choose both boxes, and that $100,000 is yours. Or you could risk getting nothing and choose box B only and get a huge, you become now a multimillionaire on your way to being a billionaire. Well, not quite, but certainly 100 million is more than a million by 100 times. So you still may be tempted to believe the demon. But on the other hand, whereas in the previous example, maybe that $10 wouldn't change your life very much and you'll go for the 10K, that 100K probably would change all our lives a lot. $100,000 if you choose both boxes, right? Would change your life, conceivably a lot, and you might be willing to settle for that. Well, I'm asking how many of you, given this model, which is the same structure, but again, change the absolute values, how many of you would go for both boxes now if you're guaranteed 100,000? Both boxes. It was fast, Susanna. You jumped on that pretty quickly. Who else? Who else would take both boxes? Now, if you're guaranteed 100,000, Anastasia, both. I'm assuming, and I'm predicting, but based on my experience, most of you would certainly go for both boxes because, hey, that 100,000 would make a big difference, right? But Naomi would still choose box B only. Okay, Naomi, you're holding out as a one boxer. I admire your courage or your conviction to do this, and it's still based on, as we've said, the demon's high predictive success rate. So you're willing now to risk 100,000 to gain 100 million. Well, most people are willing to risk 10,000 to gain 10K, right? $10 to gain 10K. It's about split. How many of you would risk 1,000 to gain a million? Maybe half of you. How many of you would risk 10, to gain 10K? Maybe all of you. How many of you would risk 100,000 to gain 100 million? So far, only Naomi. Okay, Arsh, what would you go for? You've been quiet today. Would you go in this model? Would you go for both boxes or box B only? Do you know what you would do, hypothetically? B only, right. Okay, so you see that what we've illustrated now is that there's a consistency. This model is structurally the same as this model, is structurally the same as this model. The only thing that's changed is the absolute values of the payoffs. And now suppose we're playing this game. And we're playing this game where there's 100,000 in box A, but we're playing this game in a room full of billionaires. Let's say now the people in this game, the people who are actually going to be the players in this game, let's say it's Jeff Bezos and let's say it's, the tech billionaires, right? The tech oligarchs, all of them. Bill Gates and Jeff Bezos and Oprah is in there, all the mega wealthy celebrities and the Obamas and all these people with like huge amounts of money. Okay? So imagine now all the players in this game are like mega rich. So what do you think they're going to do in this game? Are they going to pick box B only to go for 100 million, or are they going to go for both boxes and be guaranteed 100,000? Now imagine everybody playing as a billionaire, only be for sure. That's right, Jeremy. I mean, I think that's, what you would expect, because once again, if you're a billionaire, I can't even process $1 billion, but I could imagine if I were a billionaire, 100,000 would mean very little to me, and I would much rather go for 100 million and take my chances. Yeah. So you see, this is what's interesting. And I'll stop the share now because I think the point is well illustrated. What we're really saying is, and the more general point is that you cannot easily compare payoffs interpersonally. Okay, that the value of a fixed amount of money, for example, is going to be different with different people, right? The value of any prize that's on offer, the prize itself has some fixed value, all right, or whatever it is. It's the same prize being offered to everybody who plays, but the value of that prize could still differ greatly between and among the players. So the value of $100 will really depend on whether you have nothing or whether you have $1 million, in which case, if you have literally nothing, $100 represents a large amount of money to you. If you have $1 million, $100 represents an insignificant amount of money to you. So it's still the same 100, but the value of it, when you start comparing the value from one person to another person, could change greatly. So it's not easy for us to, whether we're looking at this from a perspective of rational choice theory or a perspective of economics or a perspective of sociology or social psychology, we're going to understand that these things are going to be valued differently by different players. So therefore, we will expect those things to be factored into everybody's individual decision making, and but this is also going to lead to more divergence of decision making. Okay, it doesn't change the fact that the Newcomb problem has this structure which is identical to a prisoner's dilemma. It just introduces the predictor to kind of spice things up a little bit, all right, and make it a hypothetical game rather than a real life scenario. Okay, so that's basically how it works. Has everybody got a handle on this now? At least in terms of how Newcomb's problem is similar to a prisoner's dilemma, and also obviously ways in which it is different. Okay, I would once again, good, I'm glad, Jesse, that's one yes at least. I hope the rest of you are okay with this. And just to reiterate quickly, good, okay, that's good. More yeses are good. I mean, it's fine. It's an interesting problem, right? You can try it at home. So now you have a new identity. Those of you who are in the normal model, where there's 1,000 or 1,000,000, you're either a one boxer or a two boxer, depending on your choice. And you could try this with your friends or your family and see if they're one boxers or two boxers. It always leads to interesting conversations. And the other thing I wanted to reiterate is that those of you last week who were not present during the holiday, I gave a lecture anyway, and it's in my Section M's group can access it via the Blackboard archive, and please do. It's very important extrapolation of the prisoner's dilemma to an n-player model, which has real-life implications all over the map, and you can see that on last Thursday's lecture. Today is the last official new topic, Newcomb's problem. On Thursday, I'm going to illustrate two applications. I mean, it may amaze you that such a hypothetical scenario with this demon, who has all this money and is able to read minds, supposedly, how could that have any real-world applications? Counterintuitively, and very interestingly, it turns out to have at least two real-world applications, one of them in theology, believe it or not, and one of them in biology, and we'll look at those on Thursday. Okay, Hao Hong, a very practical question. Your final essay in this course will be due on the last day of class, which is a Monday the 13th, okay? Monday, the 13th of December. Okay, and on that day, there is no class. That's a study period. Yes, the 13th. I will send you an email, and I will put it on Blackboard announcements. The rest of you who are not in my Section M will have your own arrangements with your own instructors, obviously. So this pertains only to my Section M. Again, next Monday, which is the 6th of December, we will have a review, and I will welcome your questions. I will be entertaining no new material, but only your questions about Zeno, about Anselm, about the prisoner's dilemma, and about Newcomb's problem. Any questions you wish to raise about any of those things we've looked at this term, puzzles and paradoxes, I will welcome those questions and will answer them if I'm able in our next Monday's plenary. Okay, that will be a review for you. And then the week after, which is the 13th, is a study session for you. No class, a study session. Those of you in my group, that will be your due date for essay number 3. And those of you in other groups, I'm sure at this point you have plenty of work to do, whether you're catching up or preparing for finals. So you can make use of the 13th as a study period. Okay? Fair enough? Everybody good with that? You're welcome, Anastasia, and you have a good week too. Please be well, everybody. The last day, Arsh, I won't repeat it. I'll see you next Monday for a review. Okay? That's our last day officially. Okay? And you take care, everyone. I'll stop the recording now and see you all. Prepare your questions for next week, okay? And I'll see Section M on Thursday on Blackboard. Have a good day, everybody. Bye-bye. And play the game at home. Okay? See how many of your friends and family are 1 boxers and how many are 2 boxers. Let me know next week or let me know on Thursday. Take care, everyone.